Okay, hello everybody. Lesson 2-3, solving an equation with variables on both sides of the equal sign. Today's learning objective to solve an equation involving one variable with the same variable on both sides of an equation. The language objective today is going to be to explain why inverse operations also work with variable terms that are like on opposite sides of an equation. We're going to talk about that a little bit today too. The first thing I'm going to ask you to do is take a look at the do now, which asks us to simplify the following expressions by combining like terms. Okay, no parentheses here. Remember, simplest form, no parentheses, and all like terms combined. Take a second right now, pause the video, and simplify 1 and 2. Okay, if I look at number 1, I'm looking for like terms. I have a positive 2y and a negative 6y. They're like terms. Let's put them together. Negative 6 plus 2 is going to give me a negative 4y. A negative 7 with a positive 3. Those are like terms as well. That's going to give me a negative 4. Simplest form. No more like terms to combine. Number 2. More terms here. Same job. We're looking for like terms. I see I've got a negative 5x there. I've got a positive 1x there. And a positive 10x right there. We're going to bring all those together. Add the coefficients. Keep the x. They're going to combine to a 6x. And then I've got my constant terms are minus 4 or negative 4 and a plus 8 or a positive 8. When I combine those, that's going to give me a constant term of positive 4. No like terms to combine, no parentheses. We are in simplest form. Okay? So if we start thinking about how we're going to solve for a variable that's on both sides of an equation, right? Take a look at the model and look at the steps. Step 1. The first step moving forward in this one and the next lesson are going to be to simplify both sides of an equation. Now remember, to be in simplest form, an expression must have no parentheses, which we're not going to see in this lesson, and all like terms combined. Now, when I say all like terms combined, I'm talking about on either side of the equal sign, because remember, we've got to keep one equation separate from one side of an equation separate from the other side. We must keep our equation balanced. So let's simplify the left, and then we'll simplify the right. To simplify the left, I've got two variable terms, a positive 3x and a positive x. Let's put those together to give me a positive 4x. Negative 7 is a constant term. It has no like terms, so I'm going to just bring it down. So that simplifies to 4x minus 7. On the right side, I've got a minus in front of this 3x. There are no other variable terms, so I'm going to bring down a negative 3x. I have two constant terms, a positive 9 and a negative 2. They're going to combine to a positive 7. That is always going to be step 1. Simplify both sides of the equation. We are now in simplest form. Okay, this is new because we haven't had to do it on both sides of an equation. Now the next step, this is as well new. Step 2 is to isolate the variable to one side. Right now I've got the variable on both sides. So you have to first identify which side you're going to have the variable on. Because although 4x and 3x are in fact like terms, you cannot combine like terms across the equal sign. You cannot combine like terms across the equal sign. But since they are like terms, we can identify which of them we want to eliminate by thinking about like terms. What do I mean by that? Well, if I have a negative 3x on the right, if I want to eliminate a negative 3x, what would happen if I add 3x to it? If I add a 3x to a negative 3x, a negative 3 plus 3, well, that's going to give me a 0. 0x. That is going to cancel my x terms on the right side. But again, remembering our scale here, what you do to one side of an equation, you must do to the other side. So I'm going to add 3x to this side. Only once. Why did I write it under the 4x? Because it would make no sense to write it under the -7 because -7 and 3x are not like terms. If you're going to do something to both sides of an equation, make sure you're doing it to its like term. Now, once again, we are not simply combining like terms across the equal sign. We're isolating the variable to one side by doing the opposite. The opposite of -3x is plus 3x. That cancels here. I do it to both sides. I've got a 4x plus a 3x, which is going to give me 7x. This -7 is going to come along for the ride. Now over here, I have a 0x. They canceled out. What's left? Well, this +7 is left. Bring that down for the ride. So we identified the variable was going to be on the left, so I eliminated the variable on the right by performing the opposite operation to both sides of the equation. The opposite of what's on the right was plus 3x, so I did that to both sides. Now, once again, this should look familiar. I've got a three-step equation. 7 times x minus 7 equals 7. Use inverse operations to isolate the variable. Now that the variable is on the left, I want to get it alone. So I add 7 to both sides to get rid of my variable term. I see that 7x equals 7 plus 7, which is 14. And then opposite of 7 times x is divide by 7. X equals +2. Okay. We are almost done. Once I find my solution, we always have to check your work. How do we check our work? Substitute your solution into the original equation for the original variable. Use PEMDAS to make your equation true. When I do that substitution, (2 minus 7 plus 3x equals 9 minus 3x. That's going to be my variable in there, minus a 2. What did I run out of room on here on the right? Yes, I did. Okay. So we're going to plug in our variable, x equals 2. Plug in our solution, I should say. I'm sorry. And we evaluate using PEMDAS. At this point, guys, if you have your graphing calculator, the calculator will do all this work for you. All right, but I'm going to do PEMDAS by hand, multiplication first. 3 times 2 gets done first. Now we add and subtract from left to right. 2 minus 7 is -5. -5 plus 6 is +1. Let's see if our equation's true. Let's see what we get on the right here. Multiplication first. Keep the 9 minus 3 times 2 is 6 minus 2. That's kind of ironic that that stayed there. Subtraction done from left to right. 9 minus 6 is 3. Bring down the -2. 3 minus 2 is 1. My equation's true. Therefore, my solution is x equals 2. Okay, common mistake here. When you do your check, oh, 1 does equal 1. My equation's true. Okay, so x must equal 1. Do not do that. Make sure you go back and see your solution. My solution was 2. 2 is the value of the variable that makes the equation true. Okay, let's do a couple of model examples, everybody. Model 1. Solve by simplifying, isolating the variable to one side, and using inverse operations. Check your work. The first thing that we're going to do here is draw your wall. Step 1 said simplify the left and the right. The left is simplified. There are no more like terms to combine. The right is simplified. There are definitely no like terms to combine. But if you notice in this equation, this side, the right side, only has an x term. So that's the side I think I'm going to leave my x values on. So that means I have to get rid of or move the x term on the left. How would I move a -4x? How would I eliminate a -4x? Well, the opposite of negative is positive. So add 4x to both sides. If I do that, that cancels my -4x, and I no longer have x values on the left. All that's left over here is a 20. And 6x and 4x, well, they're like terms. I can combine them to a 10x. This isn't even a two-step equation. This is a one-step equation. To get this x alone on the right to see what its value is, you got to do the opposite of multiply by 10, which is divide by 10. 10s cancel. 1x, or x, is equal to 20 over 10, or 2. Always do a quick check. So I'm plugging back in. So 20 minus 4, and I'm plugging in my 2 for x should equal 6 times 2. Let's see if it's true. PEMDAS says 4 times 2 before subtraction. That would be 8. 6 times 2 is 12 on the right side there, and 20 minus 8 is 12. 12 does equal 12. My equation's true. Therefore, I can now go and circle my solution. X is 2. Model number 2. Okay. 10 minus 12x equals negative 8x plus 14. Okay. So once again, step 1 is to simplify both sides. Look at the left. 10 minus 12x. Any like terms there? Nope. Right side, negative 8x plus 14. Any like terms there? Nope. Okay, so skip step 1. Step 2, isolate the variable. Okay, now me personally, I could isolate the x to the left side or the right side. It doesn't matter. I like to work with positive values. So my trick to tell you here is once you get to this step, look for which variable term is the smaller one. Negative 12 is smaller than negative 8. It's further to the left on the number line. Let's try to eliminate that variable term. This way we work in positives. So the opposite of minus 12x would be plus 12x, and that'll isolate my x terms to the right side, right? Because negative 12x plus 12x, well, they cancel out. They go away, leaving you only a 10 on the left side. Remember your scale, though, to keep this equation balanced. If I add 12x to that side, I've got to add 12x to the right. And this positive 14 is going to come along for the ride because I'm not doing anything to it. But I do have to combine my negative 8x with a positive 12x, which kept my equation balanced. And I'm going to see that I have now 4x. Bring down the plus 14. Okay, now we've got a two-step equation to solve. So undo this subtraction. We should be getting really good at this by now. That goes away. 10 minus 14 is negative 4. And negative 4 equals 4 times x. Well, that means I have to divide both sides by 4 to figure out what my x value is. So now I have 1x equals negative 1. Do not ever circle that answer until you check, folks. Check your work. So let's see. 10 minus 12 parentheses, because my x has to go in there, should equal negative 8 parentheses plus 14. We always substitute into parentheses, everybody. Always, 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 always. My x is negative 1. Now, this is just straight calculator work. I would hope at this point, just go and plug this in, make sure your equation's true. Double negatives is a positive. Negative 12 times negative 1 is positive 12. That gives me a 22 on the left. Negative 8 times negative 1 is a positive 8. Oh, look at that. My equation is true, therefore my solution must be negative 1. Okay, and finally, model 3. This is where we're going to actually invoke step 1, which tells us we're going to need to do some simplifying on the left and right before we isolate the variable. So look at the left. I see that I have 2 variable terms, 2x terms. 31 doesn't have a like term with it, so just bring that down. But I can combine those 2x terms to give me a negative 9x. 3 minus 12 is negative 9. Equals, all right, on the right side, this x term, this 3x here, doesn't have any like terms with it. So I'm going to bring that down first. I like dealing with the variable terms before my constant terms. Now negative 6 plus 1 is going to give me a negative 5. They're going to combine to a negative 5. So now there's no more simplifying to be done. Let's isolate the variable to one side. Which variable term is smaller, negative 9x or positive 3x? That's right, negative 9x is the smaller one. So I'm going to get rid of that one by doing the opposite. The opposite of negative 9x is positive 9x. Adding a 9x to a negative 9x will cancel it out, get rid of it. But again, here's my equation. Got to stay balanced. I need to add 9x to the right side as well. Okay, so bring down my 31 here because 31 is the only thing left on the left. And 9x plus 3x will give me a 12x. And this minus 5 has got to come along for the ride as well. And bam, here we are, two-step equation. Let's get rid of this negative 5 over here by adding 5 to both sides. So 31 and 5 is 36. And then we need to do one more step to isolate that variable. That's divide by the 12. Let's divide both sides by positive 12. So x is equal to 3. Once again, quick check. Let's go back to our original equation. 31 plus 3. Now that x has to go in there. I'll put it in a second. Minus 12. Now that x has to go in here too. Equals negative 6 plus 3. Now that x has to go in here too. Plus 1. Now which x goes in there? The one we solved for. So that's going to be a 3. Right? Replace the x's with the value that you solved for and see if it's true. Quick check. PEMDAS says multiply first. So I've got 31 plus 3 times 3, which is 9, minus 12 times 3, which is 36. You can do the multiplication from left to right. I hope you guys can see that. All right. Is negative 6. Do the multiplication, plus 9 plus 1. 31 plus 9 is 40. Add from left to right. Negative 6 plus 9 is 3. And will you look at that? Okay. Quick summary. When variables are on both sides of an equal sign, we must simplify both sides before we begin to work across the equal sign, which means make sure all your like terms are combined on the left and make sure all your like terms are combined on the right. You cannot combine like terms across the equal sign. You cannot. When you add or subtract terms to both sides, make sure you're adding or subtracting to like terms. If I'm going to add 3x to both sides of an equation, I wouldn't add a 3x to a 3 because they're not like terms. Add it to its like term. If there are no like terms on the other side, you cannot add. And finally, when solving equations for missing variables, you should always check your work. Guys, this is going to be in every summary that you see from here on out involving solving. Check your work by plugging in your answer and making sure that your equation is true. Okay? Notes, 3 models. Submit your notes as a PDF. If you have any questions about that, you need to let us know. Okay, guys, we'll see you in class.